All right, so we are going to start chapter 2. And chapter 2, we're going to focus on functions and graphs. So I know a lot of you guys don't like graphing. I kind of groan when I say we're going to graph. But we're going to do a lot of lines in the first part of this chapter. And then the second half, we're going to do some absolute value graphs, some shifting and moving up and down of things, stuff like that. All right, but we first need to talk about what a function is. So we're going to start with lesson 2.1, and we're going to discuss functions today. There are two parts. Part A is pretty long, but part B is pretty quick. Okay, so let's go ahead and talk about functions, and we're going to start with talking about relations. Relations are pretty simple. All it is just a set of pairs of input and output values. There's really no restrictions on relations. X could be 5 and Y could be 7 or something like that. It's just a relation between domain and range, between X and Y. There are 4 different types of ways to show what a relation looks like. So first type of way would be to have some points. And as you know, points are always listed as X, comma, Y. X is first, Y is second. And then what happens is we're given some points. For example, let's say that we're given the point -3, 4. We're given also the point 3, -1, and 4, -1. Okay? So that would be a relation between numbers. All of those points are in one relation. Now, another way to show the relationship between X and Y is through a mapping diagram. This is probably the least used way to show a relation, but it's interesting. If you're a visual learner, you might like it. So, for example, this could be your input values are going to be in this rectangle, and your output values are over here. And so let's just use these same points that we did for the points relationship. Your input would be -3, 3, and 4. Okay, the X values are going to be the input. And then you're going to get output would be the Y values, which is 4 and -1. And then you have to draw an arrow saying which one goes with which, like a relationship. Almost like these are the girlfriends, these are the boyfriends, stuff like that. So this girl, she likes this boy. Uh-oh. And this girl likes that boy, and that girl likes that boy too. And that's okay. All right, input, output. Another way that you have done before to represent a relation would be through a table of values. A table of values. And you call these T-charts, right? Sometimes. X and Y, T-charts. And you've done this a lot of times where you get to choose which X values you want. We'll go with these same points though. Let's say that they chose the X values -3, 3, and 4. And then those are the independent variables. I can decide whatever X's I want. But then when I plug them into my relationship, then these numbers depend on what the other numbers are. And that would be another way to represent a relation. And then finally, the last way, which you've done lots of times, would be to display a relation in a graph. So I hope you know how to graph by now. You did a lot of graphing in Algebra 1. We have an x-axis and a y-axis. And so if I'm going to graph these points, I would go to -3 on the x, +4 on the y, put a dot right there. Go to +3 on the x, -1 on the y, and then +4, -1. And that would be another way to represent a relation between two things. Don't connect them because it's just these 3 separate points. That's all it is. Okay, now with these relations, you have certain things. You have a domain, and what goes with domain all the time? Do you remember? Range. I heard it. Someone said it. Who said that? Range. Domain and range. We always talk about domain and range. Domain are the inputs, which are the X values. Okay, that's the domain. Domain are the inputs or the x values, and the range are the outputs or the y values. The domain is independent, and the range is dependent. So let's get to finally our first problem. The question is, number 1, what's the domain and the range up here with this example that I gave to you in 4 different ways? So let's go ahead and state what the domain and the range is for this problem I gave above. It doesn't matter which one you look at, they're all the same. Okay? They're just representing these 3 points, these 3 relations between x and y in 4 different ways, so they're the same. So let's look at what domain is. Domain are the x values. What x values did we have up here? Perfect. I heard it. -3, 3, and 4. And a lot of times we'll put it in set notation. It's a set of numbers. And what about our range? What's our range in this problem? Yeah, 4 and -1. And I'm not picky about order. You don't need to write it in least to greatest order or anything like that. And that's it. Domain are the x's that I see, and range are the y's. It's really that simple. Okay, so that's a relation. Now, a function is a special type of relation. A function. And that's what we're going to focus on in the first half of this class, in semester 1. We're going to do just functions, okay? Semester 2, we're going to do some non-functions. Non-functions, yeah. All right, a function, this is what a function is. It is a relation between x and y, and this is the main thing about a function. Each element of the domain, so all the x's, each element of the domain corresponds, I know that's a big word, it means goes with or relates to, corresponds with exactly 1 in the range. With exactly 1 in the range. And I'm going to tell you what that means in just a minute. I'll show you. I'll give you a picture of it. Each element of the domain corresponds with exactly 1 in the range. Okay? Basically, if you're going to look at points, the x values cannot repeat. X values cannot repeat in order to be a function. Okay? So I was helping my son with his math homework. He likes me to help him because he's like, Mom, you're pretty good at math. Can you help me? Sure. I know, right? No, the other one, the nice one. Okay, basically, it kind of showed this, and I liked it. I think when he was in 3rd grade, they were doing functions, it was kind of cute. Yeah, you did it too, you just don't remember. But there was like this function machine, right? Yeah. And a number goes into this function machine, and this function machine can be anything. It could be, let's double. It's a doubling machine. It doubles everything. Or it squares everything, cubes everything, or it adds 5 and then subtracts 2, or whatever it does. But it comes out as a number, okay? It goes in, it comes out. Now, here's what a function is. If I decide to plug in x equals 3, okay, from above, those points, 3. X goes in, something happens, boop, 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 and it pops out as y equals -1. That's great, okay? That's a function, okay? Bless you, okay? I can plug in x equals 4 even, and 4 goes in and pops out as y equals -1, and that's okay. That's okay. But as soon as I have the same function and I decide, you know what, I'm going to try 3 again. I'm going to plug in x equals 3 one more time, and I plug it in, and it pops out as y equals 5. It's not a function anymore. Okay, you can't plug in a number and get -1, and then plug that same number back in and get 5 now. Okay, it can't change its mind. So that would be not a function. Okay, so I say the x values, what's that? No, it's really, actually, there's a test we're going to do. It's actually pretty good. So if something's not a function, it could look like this. 3 maps to -1, and then 3 maps to 5, okay? So anytime the x's repeat, You can't have that. You can't have 3 going to -1 and 3 going to 5. That's not allowed. Okay. You can have, though, did you see up here? 3 went to -1 and 4 went to -1. That's okay. I'll write that down. The y's can repeat, right. So my 3 can map to -1 and my 4 can map to -1. That's fine. I'm not getting 2 different values for my x, my 1x. You can't have that. So every single element of the domain corresponds to exactly 1 in the range. I can't take my domain and it corresponds to 2 or 3 or 4 different numbers. Not allowed. All right, so here we go. Number 2. Man, I love this stuff. Anybody else? No? Okay. All right, number 2. Function yes or no. Ooh, you get a 50-50 shot on these. That's nice. And you don't have to show any work, boys, so that's good. All right, is this a function, yes or no? Was that a sexist comment? Yeah, maybe. All right, let's say we have the points 5, 3, 6, 2, 7, 0, and 5, -3. Dang, you're fast. All right, is that a function, yes or no? No. There's a really easy test, okay, a really easy way to figure that out. Look at your x's. This 5 goes to 3, and then 5 changes its mind and goes to -3. It's not allowed, okay? So that would be no. It is illegal. All right, how about this one? Let's say that I have domain, and I have range, and I have a mapping diagram. And we'll say that -3, 0, and 4 are the numbers in my domain. And my range is -2 and 10. And let's say -3 maps to 10, 0 maps to -2, and 4 maps to 10.
That's fine.
Is that okay? Yeah, it is. That's okay.
The y's are great.
The y's, yeah, the y's are all mixed up. They're weird. But the x's, only one arrow can come off the x. As soon as I draw an arrow from 4 now to -2, that's not a function anymore because 4 can't go with 2 of those, okay? So this would be yes. Yes, it is a function. Now, what if we have a graph? A graph is a little trickier to see. You can't see if the x's repeat. So we actually have another special way to determine whether a graph is a function, and it's called the VLT. It's not a sandwich. Bacon? Did you say bacon? I was thinking like veal or venison. Anyone have venison? What is venison? It is deer meat. Velociraptor, lettuce, and tomato. Delicious. Okay. All right, the VLT, this is called the vertical line test. You've learned this before. You have. Yes. To tell if something's a function, you basically imagine vertical lines going through your graph. And the vertical line test says that in order to be a function, any vertical line can pass your graph only what? Once. Yeah. Can pass through your graph only one time. Only once. Okay? In order to be a function. So let's look at some things that we're going to study in this chapter. And they're all functions. So I'll show you that they all pass the vertical line test. Number 3. Is this a function? Yes or no? Same questions. But now we're going to do graphs of them. So how about a line? Like a slanted oblique line like that. Just a line. And we're going to study these a lot in this chapter. Is that line a function? Yes. Yeah. Okay, picture vertical lines intersecting with your line. And how many times does that vertical line touch? How many times does that one touch? That one. Once. Just once. Never ever is it going to touch more than once. So yes, that line is a function. Now here's my question. Are all lines functions? No. Good. I hope you heard that, people out there. Okay. Vertical line. Yes, vertical lines are the only thing that's not functions. That would be no, not a function. Okay, another thing we're going to study in this chapter are absolute value graphs, which end up being V's. It's very exciting.
V for big V to V.
Yeah, okay, there you go. He's nice. All right. vertical lines. Let's draw some vertical lines through this. Is this a function? Yes, it is a function. Vertical lines are only touching once. What about if I take that absolute value graph and I do a sideways one, though? No, that is not. It's not a function, right. It fails because it touches twice, okay? Let's do one more. We're going to study circles next semester. How about a circle?
No.
A circle is not a
I
function.
like circles, though.
I do too, right? Okay, here's the reason why. Because everyone just goes, oh, I'm just going to do the vertical line test, and I believe it, vertical line. This is why. Do you see this x value? Let's pick this x value right here. Do you see, like, this could be x equals 2. And it's matching with y equals 4, maybe, and y equals negative 4. You can't have that. See, you can't have 2 going into this function machine and coming out as 4 or negative 4. You can't have that. It's not allowed. All right, next part, part B, we're almost done. We're going to talk about function notation. Function notation. And this takes a little bit of getting used to. When you learned this in Algebra 1, it was like really confusing. Hopefully it won't be anymore that way. But function notation basically says, let's say we have y equals 3x plus 2. Okay? And that's a line. We know that that's a line. We're going to graph those and do a bunch of stuff with those later on. But what we can do is we can rewrite this in a function notation, in function, writing. And instead of y, we replace that with something called f of x. Yeah, the groans. Yeah, I know. It's a little confusing at first, but y is just f of x. That's all it is. We replace it, and we write f of x equals 3x plus 2.
To make it harder on us?
Yeah, I invented that, actually. No, it just means that instead of saying y equals, they're saying a function of x equals. So, okay, it's not too bad, though. Number 4. This is what we're going to do. We're given inputs. And our inputs are negative 3, 0, and 1/4. Our function is f of x equals negative 2x plus 5. And our job is to do two things. One, we're going to find the outputs for all of these different inputs. And then we're going to write them as ordered pairs. In other words, we're going to write them as their points. They're points, okay, for the function. So we're going to find the outputs and then write them as ordered pairs. We're going to take one at a time. So let's start with negative 3, okay? All you're doing is this. You're taking negative 3 and you're plugging it into your function. It's like it's going into the machine. The machine says, I'm going to take numbers and multiply by negative 2 and then add 5 to it. Okay? So if I want to evaluate f of negative 3, I'm going to plug in negative 3 for x and find out what it's equal to. So I do negative 2, negative 3 goes in place of x, plus 5. And what spits out of this machine?
Function.
What number? 11. Thank you. 11. Okay? Negative 3 goes into this function. It's like plugging in x and finding out what y is. That's what you're doing. And then we're going to write this as a point. Negative 3 is the input, which is x, and 11 is the output. And that's your point. Let's try 0 now. F of 0. Okay, 0 is going into our function as x. 0 is the input. So I'm going to do negative 2 times 0 plus 5. What's my output? 5. Yeah, 0 plus 5 is 5. And then my point would be x is the 0, x is the input, y is the output, 5. So my point 0, 5. And then they make you do fractions. F of 1/4, which is not an integer. 1/4 goes in, and you get negative 2 times 1/4 plus 5. Yeah, fractions, right? Negative 2 times 1/4 is negative 1/2. What's negative 1/2 plus 5? How about 4 1/2? You can use decimals if you prefer. And our point would be 1/4, comma 4 1/2. All right, I've got one last problem. Number 5. All right, it says here that tickets to a concert, and of course they have to put in a word problem for you. Tickets to a concert cost $35. Okay? But you're going to go on one of those sites like StubHub or SeatGeek or whatever they're called. And there's going to be some kind of handling fee. Usually it's per ticket, but they're going to give you a flat rate. They're going to give you a flat rate handling fee. We'll just call it a fee of $2.50. That's cheap. These places cost a lot. Anybody buy tickets somewhere on StubHub, SeatGeek? Never been to a concert? No? My first concert was when I was 19. Guess what it was? You won't guess. Britney Spears. No. Britney Spears wasn't even born when I was 19. NSYNC. No, you guys think I'm way young. I'm way older than that. No, actually they're playing at the Rose Bowl like this next weekend. Red Hot Chili Peppers? No. Green Day. Green Day was my first concert. Okay, so here we go. We're going to write this as a function model. So the cost of tickets, we'll write C of t. The cost of tickets equals, now you guys are good at this part. Yeah, Wyatt, you're good. You have to go ahead and write how much tickets are going to cost. So what are we going to do? Wyatt, you do this one. 35t plus 250, right? $35 per ticket plus 250. It does make sense. Thank you, Jacob. It makes sense. Okay, now, how much would it cost for 4 tickets? So maybe 4 people want to go. For 4 tickets. 4 of your friends want to go, and they've put you in charge of buying them all. So we're going to do the cost of 4 tickets. And we're going to plug that in. We're going to go $35 per ticket, so times 4, plus the handling fee of $2.50. Plug that in your calculator. Beep, boop, beep, boop. Turn the sound off for sure, and it's $142.50. There you go. Done.